Alright, you guys, so this is basically talking about logarithms. So when we're talking about logarithms, what we're talking about are exponents. It is just basically a different way to write exponents. So it's really nothing more than that, and if you can just kind of keep in mind that you're just rewriting an exponent, then that'll make it a lot easier. So when you have your logarithm here, log base b of a that equals x. So when you have this format, your b is the base. The a is actually your answer. And your x is your exponent. So if I was going to write that in exponential form, then it would be b raised to the x equals your answer. Alright? So these two things are the exact same thing. So if we've got, and if you notice, here is your base raised to the x, and that's going to equal the a. So let's see what that looks like with numbers. So we've got log base 3, my x is 2, my exponent is 2, and the answer is 9. So if I were to rewrite that, b to the x equals a, 3 raised to the second power equals 9, and we know that that's true. 3 squared equals 9. So here is how you would rewrite this in exponential form. So here we've got log base 6, your base is 6, your exponent is 3, and your answer is 216. So your base of 6 raised to the third power is 216. Alright, so here 7 to the 0 power is 1. And you know that anything raised to the 0 power is going to equal 1. So if you don't know that, know it now. Then you've got 2 raised to the 4th power equals 16. And we know 2 raised to the 4th power is 16. What do you do when you have these fractions? We know that fractions in exponentials are not, that's where you get your negative exponent. So for an example, if I have 2 raised to the negative 3 power, that is actually 1 over 2 to the third power, which is 8. It doesn't mean that it's a negative number. It means that it goes into the denominator. So for an example here, I've got 4 is my base, raised to the negative 2. That's going to be the same as 1 over 4 squared, which is 1 over 16. Do you see that? All right. Now we also know that when we have a fraction like this as an exponent, do you guys remember this is basically saying 9 raised to the 3 divided by 2 equals 27. And what's that saying is 9, this is your square root, and the 3 is your power. We learned that, I think, last semester, so that's a little bit blast in the past, equals 27. So the numerator is your power, and your denominator is the root that you're taking. Okay? So here's where some fractional exponents come into play. Alright, now if we were going to take these exponential forms and move them into log forms, we basically just do the reverse. So we've got, this is our b, this is the x, and this is the a. But we want to change it into log with your b here, your a there, and that's going to equal your x. So log base 14 of 196 is going to equal 2. And that's how you would write your logarithm for that exponential equation. Same here. You've got your b is 3, the x is 4, and the answer is 81. So if I'm writing this in log form, log of 3 of 81, or I'm sorry, log base 3 of 81 equals your exponent. Okay? And here you go. Alright, so then same here. Log base 12 of 12 is going to give you 1. You just continue to rewrite it the same way. So you've got your log, your base, your answer, and that equals your exponent. Alright, so log, my base is 36, my answer is 6, your exponent is 1/2. So pause the video and see if you can do this next two on your own before you start it again. Take a moment to pause it. I really mean it. Alright, so now we've got log base 2 of 1/8 is going to equal -3. You're not solving anything at this point. All you're doing is rewriting equations. Log base 8 of 16 equals 4/3. If you were to rewrite this, that would basically be the cube root of 8 raised to the 4th power. That's how you would rewrite that in a radical form. Alright. Hopefully that's just going to take a matter of practice. So now when you're evaluating, now you're actually going to solve the logarithms. Again, it's going to start out a little bit easy because we're going to start out with just getting you used to the form, and then we will work on a little bit more difficult. But log base 10 of x is the same as just log x. So when you don't have a base, no base means your base is 10. So if you have log of 35, your base is going to be 10, and your answer would be 35. And your exponent would be x. So if you're writing this in exponential form, it would be 10 raised to the x power equals 35. There's no base, so it's automatically base 10. So let's go through these. So now we're actually going to just kind of use our knowledge to figure out what the exponentials are. So we've got log base 7. Log base 7 raised to the x power equals 49. And we know at this point that 7 squared is 49. So I'm going to tell you that x is going to equal 2. You should be able to figure that part out. We're trying to figure out what the value of this is. Log base 3 to the x power is 27. Well, 3 raised to what power gives you 27? Well, 3 raised to the 3rd power is 27. Alright, so hopefully I feel like this is blurry. Anyway, now we have a log with no base. But we know that that base is going to be 10. So 10 raised to the x power equals 100. Because this is your x. I'm using my 10 raised to that power There's your answer. 10 raised to what power is 100? X is going to equal 2. Because I know 10 times 10 equals 100, right? 7 times 7 equals 49. 3 times 3 times 3 equals 27. Right? Alright. So now I've got 12 raised to the x power equals 1. What number do I raise any number to get the answer of 1? X has to be 0. So then I've got this. 2 raised to what power is going to give me 64? 2 raised to the what power is going to be 64? Log base 2 of 64 is basically saying what is 2 raised to the power to give me 64? Well, I can't really remember that off the top of my head, so I may go to my calculator and say, all right, 2 to the 4th power. Nope. 2 to the 5th power. Nope. 2 to the 6th power. There we go. So then x equals, oh goodness, 6. All right. Same here. 3 raised to what power is going to give me 243? Well, I really don't know if I know the answer to that right now. So I'm going to go to 3 and raise it to maybe 5 and just see what happens. And I got a lucky guess on the first try. So I knew it was going to be more than 4. I wasn't quite sure. So 3 raised to the 5th power equals 243, so I know x equals 5. Alright, hopefully that makes sense. Now I've got some fractions. So 9 raised to the x power equals 1 over 81. Well, I know that 9 raised to the x power equals 1 over an 81 is 9 squared. What's going to put this in the denominator? How do I get from here to here? Well, I need to flip this to the numerator, which gives me a negative exponent, and now I can see that x should equal negative 2. Alright, just keep in mind that exponent, fractions, negative exponents. I meant to say negative exponents. Negative exponents are fractions. Right? And then if you have a fraction exponent, 9 raised to the 2/3, your numerator is your exponent, and your denominator is your root. Okay? Now, so here we've got 64 raised to the x power equals 4. Well, how do I go from 64 to 4? Well, I know that 4 times 4 times 4 equals 64. So since I know 4 times 4 times 4 equals 64, then that must mean that the cube root of 64 equals 4. But how do I show that in this situation? Well, the denominator is my root. So 64 raised to the 1/3 power is going to give me 4. And you can even test that out. 64 raised to the 1/3 third power gives you 4. So my x is going to equal 1/3. Okay? Hopefully you're catching on. Okay, now you've got this change of base formula. Basically, sometimes you are not going to have basically where it's those whole numbers, where it's nice and even like that. So 16 raised to the x power equals 64. Well, if I raise 16 to the 1 power, I'm going to get 16. 16 raised to the second power, I'm going to get 256. So it has to be somewhere between 1 and 2. It's going to be a fraction or a decimal. So I don't know how to get that. And I certainly don't know that off the top of my head. So what you do here is you do what's called the change of base formula. And what you find is the logarithm of A, the one on top, stays on top, divided by the logarithm of B. So here, to solve this, you're going to say the logarithm of 64 divided by the logarithm of 16. So I'm going to take my calculator and you can see, let's see, you go to your log right here, log of 64, and in parentheses, divided by log of 16, in parentheses, equals, and sure enough, it's a decimal point. So that's going to equal 1.5. So what that's telling me is that 16 raised to 1.5 equals 64. And I can check my answer. 16 raised to the 1.5, and sure enough, I get 64. So x equals 1.5. And that's how you figure out that. Now, if you have a Inspire, you're going to notice that they actually have let's do that. You go to your log, control log button, control log, and it actually allows you to put whatever base you want in. I don't know if you can see that because of the glare. Sorry. So I can type in 16 as my base and 64 as my, can you see that? Oh, there you go. And then press enter. And I'm going to get 1.5. So these Inspires will do your change of base formula for you. However, just because you're using an Inspire doesn't mean you have to get out of it. So I still want you to write this down. I want you to write log of 32 divided by log of 8. Then you can give me the answer. Regardless, you're going to have to do that. So you've got log of 32 divided by log of 8. And that's 1.66666. So 1.66 repeating, or 67. Okay? This basically changes both of them to the base of 10. But now we have calculators that'll do it for you. So here you've got log of 54 divided by log of 2. And after you pop that in your calculator, you're going to find it's 5.75. And here you've got log 294 divided by log 10. Now this actually should work because your log button is actually a base 10 anyway. That would give you your base 10. That should be the same as log 294 parentheses divided by log base 10. 2.47 if I round to 2 decimal points. Alright, see if you can do these next two on your own before you just pop those in your calculator. See if you can, I want you to write the equation like this and then find the answer. See if you can do that. Pause the video. Alright, so you get log 136 divided by log 4 equals 3.54. And what that's saying is basically that 4 raised to the 3.54 power should give you 136, right? Isn't that kind of what we did up there? And if we come here, and I already done this, and it doesn't actually work out completely because I'm rounding, but if I type in 4 raised to the 3.54 power, I get 135. Not quite 36 because I'm rounding. Now this one, 6 raised to what power, is going to give me 136. 1 over 36. Hopefully you guys will remember that 1 over 36 is the same as 1 over 6 squared, which is the same as 6 to the negative 2. So in this one, you really don't even have to do a logarithm. You'd find that this is, but if we did it, log to the 136 over log to the 6, you'll find it's the same thing. I'm going to predict that it should be negative 2 log to the 1 divided by 36 in the parentheses divided by log to the 6. I'm just typing in my equation just as it is, and I should get negative 2, which I do. Alright. Hopefully that helps. Do your homework.